In this video, we will try to solve the reverse conversion, which is converting from machine instruction to the assembly instruction. So given a machine instruction, we will convert it into the assembly instruction. While doing this, first we need to check any of the prefixes we have seen existing in the machine instruction or not. Now, look at this machine instruction. If we see these 2 bytes, first 2 bytes, if we see this first 2 bytes, which is 67 and 66 hexadecimal value, this indicates that there is a violation in terms of operand and in terms of the memory offset address. By assuming it to be 16-bit mode of operation. Remember again, operation is of 16-bit mode operation, and there is a violation. That means when you get a violation in 16-bit mode operation. In 16-bit mode of operation, whenever you have 32-bit operand and 32-bit address, then it will become violation. That's what it indicates. That means assembly instruction, whatever you are getting is supposed to have a 32-bit operand and 32-bit address in it. Have you understood this? That is what you have to look into, right? So one thing we know that there is a violation. Then next 16-bit, using this next 16-bit, you are supposed to get your instruction, and remaining are the displacement. Displacements here. Okay, now you see here, how do you get the instruction? You have 8B86. You have 8B86. Convert it into binary. It is 1000. Then it is 1011. Then it is 1000. Then it is 60110. Right? Now, let us convert this into our instruction. Now, first 6 most significant bits. The first 6 bits, most significant bits corresponding to opcode, right? This is corresponding to your opcode. Now, definitely this is corresponding to move instruction. So this is your D bit. This is your W bit. D bit 1 means data is going to the register. That means what is going to come here is the register, right? W bit means it is definitely more than 8 bit, right? In this case it is 32 bit because there is a violation here for 16-bit mode of operation, right? Now refer to your REG bit. This is supposed to be your REG bit, right? So referring to REG bit, it is 000, right? Now see here, there is a violation. You are supposed to have 32-bit register. Looking at the register bit of 000 here, okay? So what is the register? Register is supposed to be EAX, not AX, not AL. It is EAX because there is a violation in 16-bit mode of operation. So what is going to come here is EAX. Right? This we got. Because data is going to the register according to D bit. That means this will definitely register. Now, whatever you are supposed to get here, it will come from your mode bit. Okay, this is your mode bit and this is your R by M bit, right? Mode bit is 10, R by M bit 110. Now, where you have to refer? You have to refer to this table. Refer to this table because violation, right? Just check all these has the square bracket in it. Okay, it's not shown here. It's not shown here. Okay. Now, what is your mode bit? Mode bit is 10, right? And your R by M bit is 110. So let us now, mode bit is 10, this is mode bit and 110. It is corresponding to ESI plus D32. See here, ESI plus D32. Right. Now, that means your address is the sum of ESI 32-bit register plus 32-bit displacement. Okay. And from where this 32-bit displacement will come? This 32-bit displacement will come from this 0210. But you can say it is only 16-bit. Right? So remaining most significant bits is supposed to be 0000, 0000. That means the instruction which you get is as per this mode bit and R by M bit, it is ESI plus D32. It is ESI plus D32. So how do you write that ESI plus D32? Right, that is ESI, okay, plus, okay. Now you see here, what is stored here as a displacement is a lower byte. This is your lower word. This is your lower word. Understood this? This is your lower word. Right? In the memory, what is stored here is this is the lower byte, next to lower byte, and it follows. Right? When this machine instruction is stored in the memory, the lower byte of displacement is stored here, next to lower byte displacement is stored here, and then it goes towards the higher bytes. That means here you will have the lower byte, that is 0, 2 comes here, okay, first, then 10, okay, then 10, then it has to be made as 16-bit, right, 32-bit. So to make it a 32-bit, you just have to add 000 here. So it has become 32-bit. This is now 32-bit. This register is also going to hold 32-bit. So your complete instruction is move EAX, comma, ESI plus 32-bit displacement here. Okay. So have you understood this? Right. So now if you try to convert it back to machine instruction, if you just once again convert it back to machine instruction, you will definitely get this. And while converting back, assume that you are using 16-bit mode of operation. Definitely 100% you will get this. That's sure. Right? Okay. So now see, even though if you don't have this, doesn't matter. It can be ESI plus 10002. That means remaining bits are counted to be 000. Right? So this is the answer. So hope all of you understood this.